Sometimes ideas just have to go around the pike a few times before somebody takes them seriously. Well, hello and welcome to another episode of You and Me and Multiple Sclerosis. My name is Pam and I've been living with multiple sclerosis for over 39 years. I know that you've all heard about gold and medicinal uses for it. It's been around probably as long as I've been alive, people drinking tinctures with gold in them. They're supposed to have all kinds of health benefits. Well, now there's actually some science that's telling us that gold in solution might be useful in helping our multiple sclerosis, specifically in helping with our nerve health and our myelin repair. I'm really interested in that, and I'm sure you are too. There's been a new development recently, but before I get into that, I thought it would be good to listen to Dr. Brandon Bieber. He put out a video a while back where he was talking about the phase 2 trial results from something called CNM-AU8. It's a gold solution by a company called Clene, C-L-E-N-E. And the clinical trial results look kind of interesting. So let's see what he has to say. He tells us not only about the trial, but he tells us a little bit more about the science behind the use of gold in solution as it pertains to multiple sclerosis.
I suddenly have an interest in gold because, believe it or not, it might treat multiple sclerosis and was shown to reduce disability in a phase 2 randomized trial. What I'm referring to is a very unique and unusual pharmaceutical product, CNM-AU8, that literally is just gold, the metal in your jewelry, by a tiny pharmaceutical company, Clene Nanomedicine. This is different from any other pharmaceutical product ever developed. These literally are tiny gold nanoparticles in a suspension of water, but it's medical grade water, and they're clean surface self-formed nanocrystals, and gold apparently will naturally aggregate into certain shapes such as hexagonal bipyramids, pentagonal bipyramids, octahedrons, and tetrahedrons, and they're acting like microconductors within the cell, it's believed. These are extraordinarily small, only 68,000 or so gold atoms per nanocrystal, with a diameter of 13 nanometers or so. A nanometer is 1/1,000,000th of a millimeter. These are extraordinarily small, and they can even enter the cell and distribute throughout the body. And it's given as an orally drinkable solution. And here is what it looks like, or at least one such particle under the electron microscope. You can see it forms a certain shape. And this is what the drug looks like. It's a black liquid. Perhaps if it becomes an FDA-approved product, they'll have a fancy gold package. This looks somewhat unappetizing for the time being. As a brief aside, the same drug company is developing other nanoparticles, a zinc product thought to have antiviral, antimicrobial properties, a zinc and silver product used for infections and wound healing, and a gold and platinum product which is supposed to have anti-cancer properties. Now, no one knows for sure how CNM-AU8 could help with multiple sclerosis, but these are some theoretical mechanisms of actions. It's thought to act like a mini conductor, giving and receiving electrons, perhaps helping with chemical reactions, particularly in energy metabolism within the cell, both in the cytosol and the mitochondria. And it's well known that multiple sclerosis, particularly progressive MS, is associated with energy or mitochondrial failure within the neuron, and it may help compensate for this energy failure. It also has some direct antioxidant effects, and it may stimulate oligodendrocytes or oligodendrocyte precursor cells to develop, differentiate, and even grow myelin. I note that these effects are extremely temporary, as the drug is rapidly excreted into the bile and then the feces, so it must be given continuous if it is to have these metabolic effects. Does it get into the cell, into the brain, and have these metabolic effects? Well, this is a study using MR spectroscopy on both multiple sclerosis and Parkinson's disease, Repair MS and Repair PD, and they combined the two studies for statistical power. An MR spectroscopy of the brain looks at metabolic activity and quantifies the ratio of NAD plus to NADH, and a higher ratio would mean more utilization of energy, and with natural aging there's a decrease in the NAD plus to NADH ratio. Anyway, they combine the two data sets to create an N of 24 versus 24 at baseline, so this is a pre-post comparison, and they boosted the ratio by 10%. It was statistically significant with a p-value of 0.037. You could say they're cheating by combining these two diseases, but there is something going on here. It's almost like they're making the cells metabolically younger. And this reminds us that CNM-Au8 isn't just being studied in MS, it's also being studied in Parkinson's disease and ALS, or Lou Gehrig's disease. In Parkinson's disease, the data is just the Repair PD data I just showed you, very preliminary. In multiple sclerosis, we have a completed Visionary MS phase 2 trial I'm about to show you, and in ALS, we're the furthest along with the completed Healy ALS platform or phase 3 trial. This is a very interesting study where they didn't just compare one drug versus placebo, they looked at multiple potentially active agents, and CNM-Au8 showed some benefits in terms of survival. This is beyond the scope of this particular video. So we'll focus on MS, and the core of this video, the meat of the video, will be the results of the phase 2 Visionary MS trial. This was a study in relapsing remitting MS, people with stable disease. They had to have no relapses in the last 6 months, age 1855, and they had to have chronic vision problems due to MS. The reason for this is the primary outcome of the study was low contrast letter acuity, and they chose this because it's easy to measure a small difference, which is important for a trial with a small sample size and short follow-up, a preliminary trial. They looked at 2 different doses of CNM-Au8, 15 milligrams and 30 milligrams daily compared to placebo. Now, this is an add-on drug. More than 90% of people in the study were already taking disease-modifying therapies, and 53% were on the drugs Ocrevus, Tysabri, or rituximab. So a lot of these people were treated with highly effective disease-modifying therapies, very good at stopping relapses and new MRI lesions, which really makes sense because this drug should work in a different way, not by suppressing the immune system. It should have these metabolic effects. Now, in a sense, this study was unsuccessful in that they didn't recruit their planned 150 patients. They could only recruit 73. The results are still impressive nonetheless, and apparently their poor recruitment was due to the COVID-19 pandemic and the timing of everything. Now, in addition to the primary outcome, they also looked at secondary outcomes, I'll explain in a moment, including the symbol digit modalities test, a measure of cognitive function, the 9-hole peg test, a measure of upper extremity function, and the timed 25-foot walk, a measure of lower extremity function. And the way they did the statistical analysis is they took the 2 doses of CNM-Au8 and they put them together against placebo for greater statistical power. This was specified in advance. They also used a p-value with a threshold lower than normal, so a p-value of only 0.1, and this is used for preliminary exploratory analyses, so take the results with a grain of salt. To further explain the outcomes of the study, this is the 9-hole peg test, where you have to take tiny pegs and put them into small holes, requiring good hand-eye coordination. They test both the dominant and non-dominant hand. This is the symbol digit modalities test, and they give you a key where a certain symbol is represented by a number, and then you have to memorize this, look at the symbols, and fill in the numbers and do it as quickly as possible. It's a measure of cognitive function, and it really tests processing speed, which can be affected in multiple sclerosis. This is the timed 25-foot walk, where you simply walk 25 feet as quickly as possible. A healthy young person can do this in about 4 seconds. And this is the low contrast letter acuity chart, and basically it's not shown well on this slide, but these letters are a light gray, very difficult to see, and it's thought to be more sensitive to damage related to optic neuritis, and they test both the affected eye, the eye with worse vision, and the fellow eye, the eye that has better vision. And it's very good at picking up slight differences in visual acuity. Did people actually do better with the drug? Did it actually improve symptoms? We'll start with the primary outcome, low contrast letter acuity. Again, this is that eye chart with the faded gray letters. And you can see the change from baseline, the number of letters you could read at the end of the study versus the beginning. And you can see the placebo in the dashed white line. There's a little fluctuation, but they stayed about the same. Whereas with the drug, they gained about 3 extra letters on that eye chart, a modest but perhaps noticeable difference. Now the p-value was 0.056, which would not be statistically significant except for the fact that they said they were going for an exploratory p-value of 0.1, so they're allowed to claim victory. But much more impressive in my opinion were the results of the MS functional composite overall. This is a chart looking at all of the outcomes, not just low contrast letter acuity in the affected eye, but also the fellow eye, the SDMT, a measure of cognitive function, the 9-hole peg test, a measure of upper extremity function, the timed 25-foot walk. You can see there's a clear shift to the right favoring the drug overall, the exception being the non-dominant hand 9-hole peg test, where the treatment group did slightly marginally worse. Everything else seems to favor the drug, although of course not always statistically significant. And you can see that if you look at people who improved by a meaningful amount in more than 2 MSFC domains, 45% improved with the drug versus only 29% versus placebo. This analysis was not statistically significantly different, but it would be quite clinically significant, 16% absolute difference in my opinion. However, if you convert everything to z-scores, standard deviations from the mean compared to baseline, you can see those who got placebo, they got slightly better by about 0.05 standard deviations. But in people getting the drug, and this is taking all of the MS functional composite, you can see they improved by more than 0.3 standard deviations, a total difference of 0.28. Very clinically significant in my opinion over only a 48-week period, and the p-value was approximately 0.02. So there may be something real here. Of course, I'll also mention the side effects. This drug has been reported to cause local lip irritation and sometimes gastrointestinal side effects. From the ALS trials, it looks pretty good. It looks fairly safe. These are the data from Visionary MS, the study I just discussed. Of course, many people report mild or insignificant adverse events, but focus on the severe adverse events. This row, you can see 1 person with a low dose, 2 people with a high dose, and 2 people with placebo reported severe adverse events. With placebo, 1 person had lentigo maligna melanoma, which is localized melanoma, skin cancer. 1 person got pregnant, which of course isn't an adverse event. You're just generally advised not to get pregnant while in an experimental drug trial. With a low dose of CNM-Au8, 1 person had pneumonia and bacteremia, infection of the blood with Staph aureus, and endocarditis, infection of the heart valve, a serious infection, although this is not thought to be an immunosuppressant, so it may be a fluke. With a higher dose, 1 person needed ketamine for pain treatment and had a prescription drug overdose. Another person had deep vein thrombosis or clot, likely in the leg veins, although this was 6 months after stopping the drug, likely not related. So there's really no signal for any significant risk, at least with these small sample sizes. In terms of ongoing research for this drug, we have the open label extension of the study I just showed you, Visionary MS. So we'll see how these people do long-term taking the drug, even though they're unblinded. The Repair MS study I showed you earlier was for relapsing MS. There's a second phase of this clinical trial for non-active progressive multiple sclerosis, again looking at brain energy metabolites, and this has been funded partially by the National MS Society. And of course, in the future, we could have a large phase 3 trial and see if this drug really works or not. And I should give the caveat, particularly for drugs early in development, that a lot of these things don't actually pan out. We can be optimistic, but we really just don't know if it works or not.
Okay, well, now that we've looked at all of that, now we're ready to take a look at the article that just came out in Multiple Sclerosis News today. It was published April 18th, 2024, and it is a report on something from the American Academy of Neurology 2024 meeting. Sustained myelin nerve cell gains with long-term CNM-AU8. Findings buttress Clean Nanomedicine's plans to launch phase 3 trial in MS. So the trial has not yet launched, but based on the results from the phase 2 trial, which we heard about from Dr. Bieber, they are going to go ahead and launch a phase 3 trial. And according to the article, long-term treatment with Clean Nanomedicine's experimental oral therapy, CNM-AU8, led to signs of sustained improvements in nerve and myelin health for people with relapsing remitting multiple sclerosis over 3 years, according to new data from the Visionary MS clinical trial. And you'll remember Dr. Bieber mentioned the Visionary trial. The findings continue to support Clean's plans to launch a phase 3 trial of CNM-AU8 in MS, which may support applications toward the drug's approval. So you see a lot of hedgy type words here, right? Plans and may. We don't know for sure how this is going to work out, but like I said, they're encouraged enough by the phase 2 results that they felt it was worth the investment to go ahead into phase 3. As an MS neurologist, for me, these results are particularly exciting and provide a clear impetus for a phase 3 study. Michael Barnett, PhD, a clinical advisor for the trial, said during a talk at the American Academy of Neurology, or AAN, 2024 annual meeting, which was held April 13th through 18th in Denver and online. Barnett's presentation was titled Visionary MS Long-Term Extension, a multi-center, open-label long-term extension study of CNM-AU8 in patients with stable relapsing MS. And just so you know, I did click on that. It is at this point only an abstract that's available, or at least without some kind of a paid subscription. So I didn't go any further than that. I felt like this article would give us all the information we really needed. They go on to say nerve cells require high levels of energy for the intensive work of sending electrical signals, and problems with energy production may contribute to the progression of many neurological disorders, including MS. CNM-AU8 contains a liquid suspension of gold nanoparticles designed to boost nerve cells' energy production. And you might remember the photo that Dr. Bieber presented of the way it looks now. It's a kind of a black liquid. As he said, it doesn't look very appealing. But if it did the job, we really wouldn't care what color it was, right? This mechanism is distinct from approved disease-modifying therapies, or DMTs, for multiple sclerosis, which work to reduce inflammation in the brain. The development of adjunctive therapies that not only prevent neurodegeneration, but also improve neuronal function with measurable clinical benefit, will fill a major unmet need for people living with MS, said Barnett, who serves as a professor of neurology at the University of Sydney, in a Clean press release. And you'll see here, there's an article that was published about a year ago. Clean wins a grant to develop CNM-AU8 for progressive MS, and Dr. Bieber hinted at that as well. I think that's really the exciting thing. Of course, having progressive MS, of course I think that. But while there are many good therapies for those who have relapsing MS, once you hit progressive, the options are much more limited. So again, I'm always interested in what might be coming down the pike for progressive MS, and this might indeed be something. Well, let's go on and see what else they have to say here. Long-term gains with CNM-AU8. The phase 2 Visionary MS clinical trial, and there's the number, and this is a hyperlink, so when you click on this article, which I will have in the description, you can go out and actually look at the clinical trial. Tested CNM-AU8 against a placebo in 73 people with relapsing MS who hadn't had a relapse for at least 6 months before entering the study. All the participants had chronic optic neuritis, or inflammation of the optic nerves that connect the eyes to the brain, which causes vision problems, and were randomly assigned to one of 2 doses of CNM-AU8, either 15 milligrams or 30 milligrams, or a placebo, daily for nearly a year. Most also took background DMTs during the trial. And you'll remember from what Dr. Bieber said, the reason that they're looking at people with optic neuritis is because this test that they're looking at primarily is one where your visual acuity seems to show significant improvement taking the CNM-AU8 compound. And it's easier to test that and see actual results than it is for some of the other tests that are used to measure how we're doing with our MS. After a year, those given CNM-AU8 had significant improvements in vision, with data suggesting the therapy improved the health of nerve fibers in the brain. After the placebo-controlled study, 55 participants entered into an extension study dubbed Vision MS LTE, and there again is the clinical trial number. There, all were treated with CNM-AU8 at 30 milligrams per day for 2 years, so the higher dose, for a longer period of time, for a total of 3 years of treatment for those given the therapy in the original trial. No serious side effects related to the therapy have been documented, said Barnett, who noted the therapy has been extremely well tolerated. Earlier this year, Clean announced data that showed improvements in vision with CNM-AU8 were maintained for 3 years for those who started on the drug in the placebo-controlled part. Improvements on cognitive assessments were also maintained after 3 years on CNM-AU8, and those who switched from a placebo to CNM-AU8 in the extension study saw improvements in these measures. Repair of damaged optic nerves. Barnett's presentation at AAN included new data that showed the therapy also led to sustained improvements in the amplitude and latency of patients' visual evoked potentials. When a person sees something, an electrical signal is sent along the optic nerves from the eyes to parts of the brain that make sense of what's being viewed. Visual evoked potential, latency, and amplitude are measures of how fast and strong this electrical signal is, and are reduced when the optic nerves are damaged. The improvements in visual evoked potential in these patients, all of whom had optic neuritis at the trial's start, suggest the damaged optic nerves are repairing. MRI trial data also indicated CNM-AU8 led to long-term increases in markers of myelin repair or remyelination. Myelin is a fatty substance that wraps around nerve fibers to help them send electrical signals, but is damaged by the misguided inflammatory attacks in MS. The data collectively show not only paraclinical evidence of remyelination and improved axonal or nerve fiber function, but measurable improvements in previously fixed clinical deficits, Barnett said. This is a very exciting data set that gives hope to millions of people who are suffering from this disabling disease, said Benjamin Greenberg, MD, head of medicine at Clean. Observing such a profound clinical benefit with corresponding improvements in physiologic measures utilizing a mechanism that does not target immune system modulation has never been demonstrated in prior multiple sclerosis trials. Well, what do you think about all of this? Are you interested? Are you excited? Is this something that you would participate in a clinical trial about? The side effects look pretty minimal, and I think that's always a consideration for me and many others. If we're going to be involved in a clinical trial, or even if we're going to start taking a certain medication once it's hit the big time and the pharmaceutical companies are actually promoting it. You always want to look at that. But the side effect profile for this looks very good. So I'm thinking, if it's something that we can try, it might not hurt. Especially I'm interested in the follow-on that will be coming out someday, where they're going to look at the effectiveness for progressive forms of MS. I mean, I already have a lot of damage to my myelin. I have entire axons that are gone. Probably many of you do as well. I've often wondered, well, what is remyelination going to do for me if there's nothing to remyelinate? It would almost have to start all over from scratch, and I'm not sure anything's quite ready for that. But can this help me maintain what I already have? Because we know, even with MS that does not seem to be progressing at a rapid clip, if we can't even detect new signs and symptoms, we know that there is progression going on behind the scenes, progression independent of relapse activity. And if something like this could stop that in its tracks, then I could at least adjust to my life the way it is with the confidence of knowing it's not going to get any worse. I know that's kind of an odd way to look at things maybe, but at this point, I'm going to take my optimism where I can get it. Anyway, let me know in the comments what you think of this new old line of research. And until my next video, please do take really good care of yourself. I will see you again soon.